Okay, thank you for coming. So last talk of the day apart from the keynote or the wrapping up, so thanks for staying awake and being here still. Now in the program, the title of the talk was Structure the Unstructured, and that is still kind of the title, but the alternative title is 3 things you need to know about document data modeling, because I wanted to get that BuzzFeed style, you know, you've got to come and see this talk to it. So it could be 3 things you need to know about document data modeling, and you won't believe the part in section 3, or something like that, if you really want to get it kind of social media friendly. My name is Matthew Revell. I work for a company called Couchbase. We make a document database. It's open source. It's on the internet. You can look at it on GitHub, pull down the code, and it's really good at doing large-scale document storage on the server side. And then there's a mobile phone version that handles syncing for you. So that's Couchbase. So document data modeling, the first thing to say is that we're still learning, and there's a lot to learn. You know, document databases at scale have been a thing for probably no more than 10 years, really. Okay, so yes, we've been doing Lotus Notes for longer than that, and there are lots of document databases around, but they're always quite a niche thing. And now, as document databases become more and more prevalent in web applications and well, various different kinds of application, we're finding there's more to learn. And you know, it's not like the relational world where we've had 40 years of academic study and you know proofs and things like that show us absolutely the best way to model data for different circumstances. It's really not that at all. But there are some things that have become clear, and some things that people have learned and been able to share. And the first thing is that the way that you access the data shapes how you should store the data, and basically the data model. And there are kind of 2 axes. On the left, you know, you need to work out whether your queries are going to be predictable. Will you always know what you're going to be going for? Or are they going to be ad hoc queries where you have lots of variety to the shape of your queries and what you're looking for? And then along the y-axis, you know, where are you computing the query? Are you computing the query in your application layer or in some other part of your system, or do you want the database layer to do the computation for you? And in the Couchbase world, you know, or generally document databases, the difference between predictable and ad hoc will determine largely how you make the query, and then that determines largely how you model the data. And this talk is really mostly actually about modeling data for key value access as opposed to really intricate sub-document query. So modeling for key value is, I don't know, it might sound like, you might think, well, there's not a lot to be said about that, but I'll try and convince you otherwise. So there are some principles to observe for modeling data for a key value store or document stores. The first one is that you should aim to pre-compute your answers. So a lot of the time, you know, when we're working with relational databases, we might cache things. That certainly happens. But you know, you fire off a SQL query, and you expect it to come back within a reasonable amount of time, so you can then do something in real time with the data. And okay, yes, like I say, we do cache things. We do acknowledge that not all the time we're going to get the response back in a timely manner. But in the non-relational world, in the key value world, generally speaking, it's a good principle to think of it as a store for things that have happened before. Another kind of thing that you might want to do with key value databases is to just offload the object state to the store, and you know, see that as just a very easy way to persist your data, your object state, just to pull it back in again. And then there are a couple of things that you really need to consider when designing your documents, and that is when to embed data and when to refer to data elsewhere, and I'll explain what I mean shortly. And also, if it is a pure key value store, you really need to design your keys well. So pre-computing answers, what do I mean by that? As I touched on, we're really used to asking questions of our database. So in the relational model, the whole idea is that we take our data, we split it up neatly, we have really great shape to it, we understand it, the database understands it, and we can ask any question we want of it. Now, obviously, in the real world, we shape the data according to how we're going to query it to an extent, but really we have an almost unending supply of answers or shapes of answer from that data with a relational database. Whereas with key value stores, document databases, it's more like a library of answers. So what do I mean by that? Well, if you think about a library, you have a theory like the theory of evolution will be present in several different books. So you might have Darwin's original Origin of the Species, and that'll kind of be your canonical source. But then you go to other books which will describe the theory of evolution. And that's okay, because what's important there is the context in which you're accessing the data, or the theory. And so in a library, we're used to duplication or multiplication of data in different sources because we accept that we're going to find that in different contexts. And that's kind of how we should look at a key value store. So Martin Fowler from ThoughtWorks describes aggregate-oriented databases, or as I think of them as answer-oriented databases. So in the physical world, maybe in the 1970s, we might go into an office and do some paperwork, and we're going to make an order for something. We might fill out a form similar to this, and that is an aggregate of the data associated with that transaction. So everything that we need to complete that order is on that one piece of paper. So the customer details, the credit card details, the actual items that we're ordering are all on that one thing. And then in the relational world, what we would do is we would take that and we'd split it out into all these different tables, into rows and different tables, and store it that way. Whereas in an aggregate-oriented database, we store together the data that we access together. So instead of splitting that up into multiple pieces, we store it as a single document. And that's good for a number of reasons. One is, well, it becomes very fast because you're doing a single query just to pull out that one thing. And secondly, it makes it easier to distribute because when you are talking about having a single read operation to get all of the data associated with one answer, then you can distribute data around a cluster of many database servers, and you can afford to lose some portion of your data servers and still be able to serve reads and take writes for the other portion of your data set. So it's kind of a bit more resilient. So how does that relate to pre-computing answers? Well, this is a site called Skyscanner, which I use a lot, and it's basically a travel search engine. It's more than just a travel agency because it will also screen scrape airlines who don't go through travel agencies and things like that. So it will give you a really full market view of how to get from one place to another. So here I've done a search from Manchester, my local airport in England, to San Francisco International. And the first time that someone does that on this system, it will go out and it will take a while to poll the various travel agencies, to do the screen scraping and everything it has to do, and then it will put it all back in and display it to you. The second time that someone does that, it will just go and pull out of the database the cached result, because obviously, it would be very wasteful to do that every time. So it pre-computes the answer for everyone else until it reaches some kind of timeout or they manually click refresh or whatever they need to do. But for very popular routes, they're just pulling out that simple JSON document now with all of the flight details for that route on that date, and they've pre-computed that answer, stored it, and then it's a single request from the database. And in this case, it happens to be Couchbase. Similarly, if you have a social network and a news feed, there are a couple of ways of populating that news feed. So you could have it so that when you go in and update your status, I'm at Topconf Tallinn, it could be that then that stores that one thing in the database for you, And then when your friends come to look at your newsfeed, the social network could then do a whole bunch of SQL queries to construct the newsfeed for that person. And so I once spoke to some people building a social network, and they said that that worked to start with. But what happened was the people who most loved their service and therefore had the most connections, it could take up to 60 seconds to build the newsfeed for them, by which time they'd gone and done something more useful. So they didn't want to send people away to go and do something else. What they decided to do was every time that someone makes a status update, that triggers us off a process of asynchronously creating the news feeds that would be affected by that update. So the first thing they did was update the person's own news feed. So they then see their own status update. But then over a period of seconds, particularly if they had many followers, it would then go and update all of the news feeds for all those followers with that new status update, save it as a JSON document in the database, and then just serve that out as a very simple, quick single read from the database every time someone viewed their news feed. And so that's what I mean by pre-computing answers. We need to, if we want to get the benefits of a distributed key value store that has lots of uptime and quick responses and redundancy and all of this, then we need to make trade-offs. And one of those is that we need to consider computing our answers and then storing them whole for serving at the time. So the principle is, don't make a human being wait for something you could do asynchronously and then just store in the database. So the next thing is when to embed and when to refer to data. So you might have heard of non-relational databases as being the place where denormalization happens. So the third normal form says that you shouldn't duplicate data within the same data set. There should be canonical sources. And no non-relational databases, no SQL databases are firmly denormalized. They are very much set up to say, well, just like our library of answers, it's okay to duplicate data. It's okay to have the same customer record in different contexts, stored in different documents, different entries in the database. But also, okay, it's all right, you're allowed to duplicate data, but you don't always want to. So what do I mean by that? So this is a very simple version of an e-commerce order in a relational database. So if we start off with the order table there, that tells us, basically that says, well, the customer is customer number 40, and the order detail, the order details is here, and that relates back to the order itself, but that also then tells us how many of that product there are ordered, and so the whole thing comes together. So this is an extreme version of referring to data. We're keeping canonical versions of that data in the database and then referring. Not rocket science, this is what we've all done many, many times, right? So then how does that translate into a document database or a key value store? Well, the first thing is you could just shove it all into one big JSON document and think, well, I'm going to embed everything in one document. And that's okay. That might be okay for what you're doing. That would certainly be very fast. You're doing one lookup, probably one very quick sub-millisecond lookup compared to a bunch of SQL queries which would take a few milliseconds and disk seeks and all of this. Or you could decide to split things up a bit more. So instead of having that single document, we could refer to documents. And so we'd have the main order document there, and you'll notice that we've saved ourselves one reference because we can now embed as a JSON object, we can embed the actual line items of the order. But then we can still do these similar references. So the order ID, okay, that's our order ID, but the customer number, we can then, in our application layer, we could do a get now to get customer number 40. And so that gives us a canonical record of that customer, which relates to there. And then we have a product there, and that's product ID 1, so we can do a get for product ID 1. And so what we're doing is we're saving some disk space, I guess, but not a lot. But we're saving the risk of data going out of sync, data drifting. So, okay, so when should you embed data as one big document? Well, there are a few circumstances in which you should embed data. One is when speed is your absolute priority. So if you really want to grab that out as fast as possible and you're effectively using it as a cache, then fine. Store it all as one big thing and just get it back and serve it. Another time is when it's very slow-moving data. So when your reads vastly outweigh your writes. Why would that be a consideration? Well, if you have multiple copies of data around, of the same data, such as a customer record around a database, and you want to do you do many writes on that, then if you want to keep all those documents in sync, then you're going to have some hard work to do at the application layer, because in a lot of these non-relational databases, the database layer won't help you with that. So if you have 3 copies of that customer data and you're making many writes to update that, then you're going to have to make sure that you're making all those writes in the same place. And the vast majority of non-relational databases have no transactions, so you wouldn't be able to necessarily roll back a change if it failed halfway through. So if it's slow-moving data, you're doing lots and lots of reads, then it's probably okay just to embed it all together, and then you're optimizing for those reads. When you want to avoid duplication, again, sorry, I'm not sure what I mean by that. So let me skip over that. That's an error in my slide. Yeah, and the other thing is about when the application layer itself can keep those multiple copies of data in sync. So if you're comfortable with that duplication, or you don't mind it going out of sync, then that's another thing to consider.
Sometimes you don't want them to be in sync. You have
Right.
You want to have its own version of customer's address.
Yes, yeah. Yeah, exactly. You took the words out of my mouth. Yeah, absolutely. So you might want to store the address to which you sent a particular order as a historical record. Absolutely. Yeah. So when should you refer to data? I think most of the time, actually. You need to be careful. You need to work within the limits of the system that you're using. So if the database system you're using is quite slow for reads, for example, it's an eventually consistent system that's going to give you 3 copies of the data back and ask you to resolve conflicts, then maybe embedding is a better way to go, because you'll have fewer conflicts to resolve, perhaps. But if you have something like Couchbase, which has built-in caching and is strongly consistent within a cluster, then it's quite safe to embed things, to refer to things and to have these canonical versions of documents. So if consistency is the priority and you don't want things to go out of sync at all, then have canonical copies of the data and just refer to the key name in the document where you would otherwise embed that data. And another time to really go for references is when the data has either unlimited or very large growth potential. So if you imagine you're creating, say, an instant messaging system, and you're storing a conversation between 2 people as a set of documents, if you stored that as a single document, that message conversation could go on for years. And I won't name the company, but a very large online retailer once described at a meetup how they'd built an instant messaging system for buyers and sellers. And a buyer and a seller became friends. And because they'd started their conversation around this particular transaction, they went on talking for years. And in the end, because it was an eventually consistent database, with all the conflicts that arose and everything between the data, they ended up with, I think, 3 20-gigabyte documents or values in the database. Sorry, not 20 gigabyte, 20 megabyte documents in the database that were then basically growing larger and larger every day, and with every conflict it compounded more and more, and so they ended up with very large documents that were slowing down the entire network and the database every time these 2 people had a conversation. So what they did instead was they then built a master document that then just had links that referred to a paginated version of the conversation. And so, yeah, if you have very large documents in most of these systems, you will slow things down massively. So for Couchbase, the upper limit is about 20 meg of really what you want to do. For something like React or something, you're talking about 2 meg. So you really don't want to go beyond really a few 100K in a lot of cases for your documents. So refer to documents where you have very, very large growth potential. Key design. So if we're talking about a pure key value store, then the key is your only route into the data. Now, the actual truth is that in most of these databases, you have some other query mechanism that will give you another route in. But if you want to use key value because it's quick and so on, then you need to be very careful about how you design your key, because that key is how you're going to find your data again. It's your index, it's your query, it's everything. And generally speaking, it seems that there are 3 broad types of key. There's some mix of human-readable deterministic, so something that's come from data that you can easily get from elsewhere. So for example, if it's a user profile, then an email address would be a really great way to key that user profile, because every time someone logs in, you could say, well, your username is your email address. So they've given you their email address, you now have a route into that data. Then, there's GUIDs and things like that, computer-generated keys, and then compound keys, which have a semantic, which basically tell the story of what the data is in there and combine other bits of human-readable and computer-generated. Let's look at an example. Here we have a simple Java class for a user. Turn that into a JSON document, and so how do we key that? Well, if we key it by email address, like I say, we have a really simple route in. That's great. But what happens when, I don't know, I want to change my email address? I put my personal email address instead of as my username instead of my work email address. Well, there are a couple of things to do. You could destroy that document, recreate it, keyed under the new name. That would be one way of doing it. Feels a bit messy. I don't know. Maybe it's not, but it feels dirty to me somehow. Or you could change the body of that document there, so it just has the email address that you're using as your new email address, and then it's like a referral. Or you could have some kind of computer-generated key name that is entirely unrelated to the data. And then that means that if I change my email address, I'm not going to have to change the key name. So how do we do that? So you could use something, most key value stores have an atomic data type, atomic counter, sorry. So you tell it to increment the counter, and it gives you back whatever the new larger number is. So in this case, we call it the counter key pattern. So you call the counter, you get the number back, you use that number as your key name. So let's say it's 1001. So instead of using my email address, we use the 1001 as the key. And then suddenly we've lost any way of finding that document ever again, because 1001 is meaningless. Unless we are kind of nasty and insist that everyone now logs in with some meaningless string of numbers. I mean, we could do that. Another way would be to have that referral document that I mentioned. So we then, as part of creating a new user, we then add another document that is keyed on their email address, and the body of that is simply the 1001, the randomly generated number that we've come up with. So then when we want to come and find a user, we do 2 lookups instead of 1. We look up the email address. That then gives us the counter number, the 1001 back, because that's the body of that document. And then we do a get on that 1001, and that gives us the user profile. That might seem like a lot of extra work, but compared to doing a SQL query, it's actually fairly lightweight. You're doing a couple of requests, at most a couple of disk seeks, or maybe a couple of hops across the network. And key value stores, particularly something like Couchbase, you're talking about very, very fast lookups anyway. So it's not like it's going to be noticeable. I mean, I spoke to someone a few months ago, and one of their queries to do, one simple thing actually made 38 lookups in the database. And users were none the wiser. It wasn't like they were sitting there waiting for things to happen. And that's probably an extreme case, but yeah. And then you can take this a bit further. So here I've used a U and then colon colon as a separator. So I now know that in my application, if I ever come across or ever want to find a user document, I put the U colon colon in front, and that will tell me what sort of document is there. So again, this is kind of semantically loading the key name to tell us what's going on. And so I can do that counter lookup, and then I can do all sorts of other effectively manual secondary indexes. So I could do it on a Facebook API key, another email address, a username, a Twitter ID, whatever. And so long as I'm disciplined in naming the keys in such a way that tells me what the content means, then I can always find that data again, and that's fine. So I mean, looking at these compound type of keys, what we could do, so I've embedded a lot of data here. I mean, it's not a lot of data, but let's pretend it is. So let's pretend that the products viewed is a really long list of numbers. I've looked at a lot of products. That might become unwieldy, and so we might want to separate that out. One easy way to do that would be to then just have another record, and the key name has an appendage on it that tells us what's inside there. So I know that predictably, every time I want to find user 1001's viewed products list, I just look up the same document name or key name, but I just append products viewed onto the end of it. So it's not rocket science, but it's what a lot of people do. Similarly, I have a products list, and then I want to look up a product. Well, anything with P colon colon I know is going to be a product, and I might want to separate out the link to the image. So you're basically trying to keep the size of your document manageable. You're trying to have key names which tell you about what's in the document. Because key value stores are dumb. They won't do anything for you without some kind of payoff. Now, like I say, most of them now have some other kind of query mechanism. So Couchbase is really actually a full-on document database rather than a key value store alone. And we have a query language called Nickel. Now, if you're in my last talk, I was talking all about Nickel, so hopefully I won't bore you by talking about it again. But briefly, Nickel is a SQL-like query language for querying JSON documents. Nickel means non-first form query language, because the first normal form states that you can't embed data, you can't have nested data. It has to, all the data that you store in the database has to be at its most atomic, smallest level. And that's not the case with JSON. JSON, we're nesting things all over the place. And so it'd be a shame to lose that nestability just to meet the first normal form. So Nickel is a version of an academic language called SQL++. It lets you dive into arrays, it lets you handle missing data gracefully and things like that. So I won't go massively into Nickel. You can look up the video of my other talk. But it looks like something like this. And so it looks like SQL, basically. And you can do joins between documents and so on. But why is it interesting to data modeling? Well, you have to then start thinking about, if you're going to query the data like this instead of as a key value store, you need to start thinking about how to shape the data to suit that. And again, Nickel's quite a new thing, so there's a lot of lessons to be learned, and we don't know all of the best practices yet, but effectively what you're doing is you're making a series of should I embed or refer decisions. And if you have a powerful query language like this, then you probably want to do mostly referrals, because you want to keep the shape of your JSON data. You want to, and the fact that there's no impedance mismatch. You want to keep the fact that it's easily distributable around the cluster, but also you want to have the rich queryability that we're used to with SQL. So lessons for working with Nickel and data modeling are really quite simple. Refer as much as possible, and when you want to do joins, you need to have the primary key of the other document inside the body of your right-hand side. So if you want to join an airline route to the data about that airline, then we would store the airline key name inside the root document. We can then do a join on that to then pull that back and return it all as a single JSON object that comes back. So like I say, there's not a lot right now to be said about modeling for Nickel and for these rich query languages that are now available in document databases, except that you're embedding, you're referring, and really you want to use a type in your JSON documents so that you can as part of your query, you can say, well, pull out everything where the type is airline or the type is airport or whatever. And really, like I say, it's not rocket science. It's all fairly standard stuff. So I seem to have finished a little bit early, I think. So if you're interested in this kind of thing, and you're interested particularly in Couchbase, we have a developer portal where you can find out more. We have forums where you can ask questions. And yeah, you can find me on Twitter as Matthew Revell. I would say that I'm going to hang around and answer questions, but I'm actually going to get in a car and go to the airport, so sorry about that. But I would love to come back to Tallinn sometime because it's a beautiful city. And thank you very much for your time. Thank you.